of water, H2O. Now, how have I said you must always look at water in organic chemistry? So always told you water must be seen as HOH. That means you are removing a hydrogen atom, you are removing a OH group. That means during this dehydration of alcohol, one hydrogen atom and one OH group is removed from where? From the alcohol itself. Now remember, this is different from drying. Drying is different, dehydration is different. If I have water on my skin, all right, I take a towel and I wipe it off, that water is only on the surface. It's not inside my skin, inside my body. That is drying. So that means when carbon dioxide is dry, it becomes dry carbon dioxide. It's still carbon dioxide because there's no alteration in the molecule of carbon dioxide. All right? But if oxygen is removed from carbon dioxide, then carbon dioxide will become carbon monoxide. So the same thing, when you remove water from alcohol, it cannot be alcohol anymore. Why? Because you've removed one hydrogen atom, you have removed one hydroxyl group, OH called the hydroxyl group. Therefore, alcohol has to undergo a change. So let's see what change does it undergo. So for that purpose, I'm going to use ethanol as an example. So this is ethanol. CH, H, C, H, 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 OH. This is ethanol. Learn me understand it. So in dehydration, what will happen? In dehydration, one hydrogen atom and one hydroxyl group will be removed. So let me mark that one hydrogen atom. Let me mark one hydroxyl group. These two is going to come out. Now, how will they come out? They are coming out as water. That's why we call, that means the alcohol has been dehydrated, has undergone dehydration. Okay, so that part we are okay. Okay, now, what will happen to the molecule? So, let us look at it. So, what about this hydrogen? That remains. What about this carbon? Remains. What about that hydrogen? Remains. So goes for this carbon, this hydrogen, this hydrogen. What about this hydrogen? Gone. What about that OH? Gone. Therefore, that's how the molecule will be. But then there's a problem. The problem is carbon cannot have 3 covalent bonds. All carbon atoms, in order to stabilize themselves, they must have 4 covalent bonds. Therefore, these 2 carbon atoms would automatically form a double bond between them to complete the 4 covalent bond. Learn with understanding, pick it up. Go through in your mind what I said, how dehydration works. All right, so you can see. So once this has become, take a look and see whether you can identify that. So the moment you see a carbon-carbon double bond, you know that's an alkene group. And since it's 2 atoms, 2 carbon atoms, therefore it becomes ethene. And what happens to that? And therefore it becomes H2O. Now let's summarize. Therefore, when an alcohol undergoes dehydration, that alcohol will become an alkene and water will be released. This is the dehydration. All right. So you already understood in general what dehydration is all about. Now let's go to the details. A few points which are known as examination pointers. Number 1, look at very carefully. This hydrogen atom combines with this OH. Now the question is, can this hydrogen and this OH combine and cause dehydration? Can that happen? Okay, you think for a moment and tell me. So that means in your exam, I could have marked A, B, C, D, and E. So I can say during the dehydration process of this alcohol, the OH group will combine with which hydrogen atom? will combine with which hydrogen atom and will be released as a water molecule. Is it C? Is it B? Is it A? Is it D? Is it E? Which one? Can you see? That can be an exam pointer. So for that purpose, I'm asking you, tell me which are the possible hydrogen atoms. All right. Now, if you're see, no need to memorize. If you have thought, let's say these two comes out. If these two comes out, how is this carbon going to stabilize itself? That's why I explained to you. All right? This carbon and this carbon must stabilize itself by forming 4 covalent bonds. This is already stabilized. So this fellow need not combine with this to stabilize himself because he's already stable. Now this one is lacking 2. So how? So in other words, the hydrogen cannot come from the other carbon. That means, in other words, if this carbon contributes to OH, the hydrogen must come from the next neighboring carbon. It must come from the next neighboring carbon. All right, take it down. Make sure you know that. That means if this is your OH group, from this carbon contributes to OH group, the hydrogen cannot be from the same carbon. Cannot be. So the answer is A, D, C, A, D, E. Any one of these can. Remember I told you last time also, this hydrogen, this hydrogen, this hydrogen are considered the same. You just can rotate them. So any one of these hydrogen is possible. That's pointer number 1 for examination. You have to know, put a note before I go to the next pointer. All right. Now, if ethanol undergoes dehydration, ethanol undergoes dehydration, ethanol will become ethene and you get water. Okay? If propanol undergoes dehydration, propanol will become propene and you will get water. You can see the trend. We can see the trend, although we are going to work on it shortly. Okay? Exam pointer number 2. Now, there is one alcohol that cannot undergo dehydration. Among all the alcohol, there's one alcohol that cannot undergo dehydration. A, state for me which is the alcohol. B, why? Pink, all of you. The answer is methanol. Why? Because methanol has only one carbon. What did I say about the hydrogen? See, this carbon is already contributing the OH. The hydrogen must come from the neighboring carbon. Methanol does not have a neighboring carbon. It has only one carbon. Therefore, methanol is the only alcohol that will never undergo dehydration because it only has one carbon. So methanol cannot be dehydrated among all alcohols. It is in your notes. I'll fill it up afterwards for you. So remember, that's exam pointer number 2. And I want you to know the reason why. Because the carbon must come from the next hydrogen. Okay?